Hello students, my name is Nirbhay Jadhav and I am here to teach you physics. This lecture is for class 7 and we are going to discuss the topic measurement of volume from the chapter physical quantities and measurement. So let us begin with the video. I hope you have watched the previous video in which we have discussed about measurement of area. Right. So let us start measurement of volume. Actually, what the volume is. Already you have studied in your previous class that volume is nothing but the space occupied by an object, and the unit in which the volume is measured is meter cube. The lower and say more convenient unit of volume is centimeter cube. So if you are measuring for a small quantity, so it can also be used in a centimeter cube. So let us see the conversion. Say 1 meter cube. When I say meter cube, it means it has a power 3. So can I write as a 1 meter into 1 meter into 1 meter? And we know that 1 meter is equals to 100 centimeter. So instead of 1 meter, I'll write down 100 centimeter, 100 centimeter and 100 centimeter. So after multiplication, see how many zeros we'll get? 1, 2, 3, 4, 5 and 6. So total 6 zeros we'll get. And look at this, centimeter into centimeter into centimeter. So 3 times centimeter is there, so we'll get centimeter cube. So total 6 zeros, so we'll write 10 to the power 6 and 3 times centimeter, so centimeter cube. So can I say that 1 meter cube is equals to 10 to the power 6 centimeter cube? Okay, so that is the conversion from the higher unit to say multiples to submultiple. So our next topic is the volume of regular solid. How you will measure the volume of a regular solid. Say here on the screen we are having a few regular solids just like a cube, cuboid, cylinder, sphere and cone. Already you have studied these formulas in your maths, that how you are supposed to calculate the volume of a particular solid. Say like cube is there, so say this is L. Okay, so L into L into L. Generally in mathematics we have studied that is a cube. Okay, that is nothing but side into side into side. While for cuboid we have length, height and breadth. So what will be the volume? That is L into B into H. Similarly you have studied for the sphere, cone and cylinder as well. So we are not discussing that much in detail for this, because already you know this formula, you have studied in the mathematics, right? So let us quickly move to the next one. That is measuring the volume of a liquid. Already we have discussed that we have a particular formula for measuring the volume of a solid. Now we'll discuss for the measuring the volume of a liquid. So liquid is generally measured in what? Liters. Whenever you go to purchase a milk, obviously you are purchasing a pouch, right? That is a 500 ml or 1 liter. So that liter is nothing but a volume of a liquid, and it is measured in a liquid. While when you purchase a small pouch, that is a 500 ml, so that is a submultiple of a liter. So that is why it is written that meter is a submultiple of a liter. It means it's a smaller unit. Okay, so can I say that 1 liter is equals to 1000 milliliter? If you purchase a 2 pouch of milk, right, 500 ml and 500 ml, so 500 plus 500, it will become 1000. Okay, so 1 liter will equals to 1000 milliliter. So in the next line it is written in the short form like 1 liter, L means liter, equals to 1000 ml. But 1 centimeter cube is equals to 1 milliliter. Now we have to focus on this, because we are going to use this particular say formula or say equation, that 1 centimeter cube, or say measurement 1 centimeter cube is equals to 1 milliliter. So can I say that 1 liter equals to 1000 centimeter cube? Okay, just we are going to replace here this portion, milliliter has been replaced by centimeter cube. Okay, so why? Because just now we saw that 1 centimeter cube is equals to 1 milliliter. So what we'll do in this case, that 1 liter equals to 1000 centimeter cube. Okay, so just in the previous slide what we saw, that 1 meter cube is equals to 10 to the power 6 centimeter cube, right? So here see how many zeros are there, total 6 zeros are there, 1 2 3 4 5 6. So just what we saw in the conversion from 1 meter cube to centimeter cube, we are using that particular say unit. So 1 meter cube is equals to 10 to the power 6 centimeter cube. Now can I write this, if I split this, say 1000 into 1000 like this? How many zeros are there total? 6 zeros are there. Here also look, 1000 into 1000. So how many zeros are there total? Obviously 6 are there. So just I have split 10 to the power 6 into 1000 into 1000. So now this 1000, so I will write as it is. But this 1000, this second one, 1000 centimeter cube, in place of this I will write down 1 liter like this. That 1000 into 1 liter. So 1000, so you will write as it is. But in the place of the second one, what you are supposed to write, 1 liter. Why? Because just now we discussed that 1 centimeter cube is equals to 1 milliliter. So instead of this ml, we will replace the centimeter cube. So what we will get, that 1 liter is equals to 1000 centimeter cube. So instead of 1000 centimeter cube, can I write 1 liter? So that is what I am doing in this case. In this case, 1000 centimeter cube, I will write down 1 liter. So 1000 into 1 liter will be what? 1000 liter. So can I say that 1 meter cube is equals to 1000 liter? In the previous case, we have discussed that 1 meter cube is equals to 10 to the power 6 centimeter cube, right? While here we have just derived that 1 meter cube is equals to 1000 liter. Okay. So if you have any doubt, just take a screenshot of this page and just try to understand this. Okay. Or you can rewind this and again start to understand. Okay. So let us move to the next one. That is the measurement of a capacity. Now many of you will have a doubt that why you have discussed the measurement of a volume for a solid, then measurement of volume for a liquid. Where is gas? So if you remember, gas doesn't have a volume, right? So we are not going to measure a volume of a gas. Okay. So here is our next topic, that is the measurement of a capacity. Now what is capacity? Capacity is nothing but a volume or a space inside a container. If you take a glass, okay, the space which is inside the glass, the empty space, that space is known as the volume. Okay, that is you can, in the other words, you can say the capacity of that particular container. If we say we are having a two vessel, say one is the glass and one is the pot. So who is having the which vessel is having the more capacity? Obviously the pot. Okay, because the pot is having a more space inside it compared to the glass. So there are some common measuring vessels we are also using in the lab as well as in our practical life. So let us have a look over there. So this is a cylinder or measuring cylinder, or say graduated cylinder. Then this is obviously, you know, that's the syringe. And burette, again it is used in a chemistry lab. Pipette, same, used in the chemistry lab. Then volumetric flask, you have a, say, conical flask, measuring conical flask. Then beaker you have, okay, tumbler you have. So these are what, say, measuring vessels. And this is the most common one. This milkman use this. If you want a 500 ml of milk, he will take this container and will give you. So these are the common, or say, the instrument which are using in our daily life. Okay, so this is how we'll measure the capacity of a liquid. So let quickly move to the next one, that is the measuring volume of an irregular solid. Okay, for regular one we just discussed the formulas, right? If a cube is there, that is the side into side into side, this is the side cube, or say a cube. If a cuboid is there, then length into breadth into height. But what if we are having a irregular solid? Now in that case, how we are going to measure it? Okay, so let us discuss that. So irregular solid have no definite shape, or say no definite dimension. So as a result, we cannot use any physical apparatus, okay, for measuring the say length, breadth and height. After that we'll use a formula. So that thing is not possible for an irregular solid. So then how we are going to do this? For that we are having a two instrument, that is a measuring cylinder or say overflow jar. Using these two instrument or say okay, let us keep a instrument only or say apparatus. We are going to measure the volume of a solid, that is the irregular solid. So what happens whenever a solid is immersed in a liquid, an equal volume of the liquid is displaced by the solid. Okay, to understand this, let us assume a small swimming pool is there, right? And one small fellow jump inside it. What happens? Only few amount of water will be displaced by his body, or say only few amount of water will be say overflowed by his body. But what happens if a huge fellow, okay, very fat fellow jumps inside the swimming pool? Obviously large amount of water is going to be displaced. So that is what it says, that whenever you immerse the solid into a liquid, that equal amount of liquid is going to be displaced, okay, of the same volume of that body. So let us discuss with the experiment one. Say first is the measuring cylinder, right? We have two things. The one is the measuring cylinder and second is the overflow jar. So first we'll discuss that is the measuring cylinder. So here is the case in front of you. In the first case, when we are not having any irregular solid immersed in the say this cylinder, so what is the result it's showing? It is showing that it is a 600 ml, right? Can you see this? It is a 600 ml. So now after when you immersed a irregular solid into the measuring cylinder, what happens? Now the water has been raised from 600 to 800. So now again we have to do a small little calculation for that. That what is the present reading? That is a 800 ml. What was the previous reading? 600 ml, right? So 800 ml minus 600 ml, that will give you 200 ml. Okay, so can we say that the volume of this irregular solid is nothing but 200 ml? Now can we say 200 ml? No, we cannot say 200 ml. What we discussed, that 1 meter cube is equals to, or say 1 centimeter cube is equals to 1000 ml. So we have to convert this ml into a centimeter, okay, centimeter cube, like this. After that you cannot say that a particular solid is having a volume of 200 ml. We have to convert it, okay, right, into meter or a centimeter cube. Okay, now let us look to the next one, that is the overflow jar. Now what will happen in this case? So initially you need to fill the water up to this level, right, so that it does not overflow, and this jar will be empty. So as soon as now you immerse the solid, irregular solid or any regular solid into it, what happens? The few amount of water that is equivalent to the volume of this solid will rise, and obviously the raised liquid is going to overflow from this point, and it will fall into this jar. And after taking this jar, you can see, you can calculate the reading from this jar, and you can say that the volume of that particular solid is how much. Okay, so these are the two case, means using these two apparatus you can calculate the say volume of a irregular solid. I hope you have understood, and you have no doubt regarding this. Still, if you have any doubt, please be free to comment in the comment box, and please keep watching this video. Thank you.